This video is about using our TI-84, or if you have a TI-83, you can use either of these calculators to find the equation of the regression line and the correlation coefficient of a bivariate data set. And the first thing we have to do in order to get this to find the regression line and correlation coefficient of a data set is we have to turn on the diagnostics. And the way we do that is, you see it says catalog right above the 0. So I'm going to go second catalog, and it pulls up this list. And I'm going to scroll down and find diagnostics. It's right here. I don't want diagnostics off, I want diagnostics on. So I enter that. I hit enter again. My calculator says done, which means the diagnostics are now on, and it can calculate the correlation coefficient for us. So the next thing that I'm going to do is I'm going to go straight to the stat menu here. This button stat gives us all the statistics tools on this calculator, and I'm going to edit my lists of data. So this is L1, L2, L3. These are lists of data, and we're just going to be working with a bivariate data set. And so I'm going to enter some numbers here from a problem that I'm trying to solve, and I'll just show you the problem on this problem set here. It says that the marks obtained by 8 candidates in the physics and chemistry class, their test scores are given in this table, and we have to answer a bunch of questions about that, including letters A and B, which says write down the product moment correlation coefficient, or in other words, the correlation coefficient, and then write down the equation of the regression line, y equals mx plus c, I guess, in this case, whatever you want to call your y-intercept. But in order to get that information from this data, we're going to use our calculator. So I'm just going to start entering the physics scores in list 1, 6, 8, 10, 11, 10, 5, 4, and 12. And then I'm just going to go over to list 2. I'm going to enter the chemistry scores. And those are our y values, 8, 11, 14, 13, another 11, 7, 5, and 15. And now that those are in there, I can go back to the stat menu, and I'm going to go to calc, and I just want to calculate the linear regression. It's item 4 on this menu, and just hit enter. And yep, we want to use x values list 1, y values list 2, and then you can leave the rest of these blank, and then just calculate. And there it is. It tells us the structure of the equation, y equals ax plus b. And a, our slope, is about 1.15. B, our y-intercept, is about almost 1, a little less than 1. And then it gives us the square of the correlation coefficient, r squared, and then also plain old r by itself, 0.965. So it looks like this data is actually pretty tightly correlated, or strongly correlated, I should say. It has a correlation coefficient that is almost 1, and it's positive. So in other words, kids who do better on the physics test tend to do better on the chemistry test, is what that tells us. We can also look at the graph of this data that we put in. Now, normally if I just go to the graph function, it just shows me my x and y plane. But I need to turn the stat plot on if I want to see my data points. So I'm going to go second stat plot. I'm going to turn the stat plot on. And then now when I go to the graph, I can see at least some of my data points. And I know that my data is basically between 0 and 20, let's say. And so I can set my window, minimum 0, maximum 20 for x, scale of 1 is fine. Y minimum 0, maximum 20, and and then go back to the graph. And there's our graph. And you can see that the data does appear to be pretty tightly correlated. They're all pretty close to a particular line. So we can trust our, let me go back here, stats, calculate linear regression. So we can trust that our correlation coefficient is going to be quite high and positive. So that's how you use your TI-84 or your TI-83 plus to find the equation of your regression line and the correlation coefficient of your regression line.